All right, guys, here's example 6. I'm doing it on a separate sheet because I just did it and I substituted something wrong, so didn't want to give that to you, so I'm going to do this over again. It says a 13-foot ladder leans against a vertical wall, and you see my kind of drawing here, but I'm going to draw it again over here, okay? So here's my vertical wall, and then I've got my 13-foot ladder, and okay, I'm just going to go ahead and say that's 13 feet. That's not changing, okay? And then it says if the lower end of the ladder is pulled away at a rate of 2 feet per second. So we've got this, and we're saying if this lower end of the ladder is getting pulled away, right? So I'm going to call this X and call this Y. Doesn't really matter, but, and then we want to always write, well, if you notice what kind of shape we just made, it's a triangle, okay? So that we like to know the shape, triangle, okay? And in fact, it's a right triangle. And then we always like to write what we're given, okay? So it says that the lower end is pulled away at a rate of 2 feet per second. So that means that if we're pulling this away, right, it's going to extend out like this, okay? What's going to happen to this side, this X side? It's going to get longer, right? And similarly, this is going to, this Y side is going to get shorter. Okay, so these lengths of these sides are changing. Y is decreasing, X is in fact increasing. So what they actually gave us here is the end is being pulled away at a rate of 2 feet per second, which means that X is actually increasing at a rate of 2 feet per second. So they just gave us dx dt, the way X is changing with respect to time. Okay, and they said that it is 2 feet per second. And we know that it's increasing because you can see it's getting bigger. Okay, and then we like to write what we need to find. And what we need to find is how fast is the top of the ladder coming down the wall. Okay, so I guess at the instant the top of the ladder is 12. So that's another given. So part A is saying when the ladder is 12 feet above the ground. So this is the feet above the ground, right? So when this value is 12. So when Y equals 12, right? Okay, and then part B is saying, well, when Y equals not 12, but 5 feet. Okay, cool. And then we want to know what we want to find. We want to find how fast the top of the ladder is coming down the wall. So we really want to know at what rate is Y changing, okay? At what rate is Y changing? And mathematically, we can write that as dy dt. Okay, that's what we want to find. And then the last piece are the equations. Okay, well, there's only one equation we really know down pat that relates 3 sides of a right triangle, and that's the Pythagorean theorem. And I'm going to use these variables, x squared. I'm going to do x, y, and we'll do c for the hypotenuse as usual. So x squared plus y squared equals c squared. And in fact, since we're looking for dy dt, the change, right, we're going to have to take the derivative of this. That's going to be helpful. So the derivative of x squared is 2x, but with respect to time, dx dt. Same thing with the y, 2y dy dt. And again, c is 2c dc dt. Okay, now we have everything to solve this problem. So let's do part A. And for these, since x and y are dependent on each other with all these sides, we're actually going to have to draw our own triangles, right? For these, where we know that the y value for this part A is 12, and our x value we have to find. Okay, so we have 13 and we have 12, but we're missing this x. But that's a simple fix because we know the Pythagorean theorem, x squared plus 12 squared equals 13 squared, right? So that's going to give us x squared. Well, if you do it all out, you're going to get x equals 5, okay? And so now that we've got all 3 sides and we have our rate, we can find this, okay? And this is what we're looking for, dy dt. That's what we're looking for. Again, go back to what you wanted to find, okay? And so if we just plug this into the equation, we've got 2 times our x value, which we just found to be 5, times dx dt. Well, did they give that to us? Sure, right here. 2 plus 2 times our y value in part A is 12. dy dt, again, that's our variable. That's what we want to find, okay? equals 2 times our c value, that's our hypotenuse of 13, and then dc dt. Well, you're like, Missy, I don't have dc dt. Okay, well, you can find it very easily. It takes a little bit of thinking, but this is talking about the rate of c, which really, c is our ladder. Okay, so at what rate is the ladder changing size? Well, does the ladder ever change size? No, it's a ladder. It's sliding like down and up, but the actual size, 13, is never changing. So when you take the derivative of 13, a constant number that is never changing, the derivative of that constant number is 0, right? And so that makes our thing a little bit easier to solve here, because what we're going to get is 0 on this side. And then 2 times 5 is 10 times 2 is 20, plus 24 dy dt. And if I subtract the 20 to the other side, negative 20, and then divide 24, I get a rate of, and we'll keep it in a fraction, negative 5.6 feet per second. Nice. All right. And part B is going to be exactly the same, except what changes are our y's and x's. So I'm going to draw another triangle here, doing exactly what I did up here, but with different x's and y's. So I know my x in this case, I know my y in this case for part B is 5. Okay. And then x, well, this c is still 13. And then again, if you do the Pythagorean theorem, you're going to get x squared plus 5 squared equals 13 squared. Well, we just did that. So, but our variables were switched around. You can do it again, but you're going to get x equals 12. Okay. And great. Now we can plug it into our formula again. And this is what we're looking for, dy dt. So it's going to be 2 times our x, which is 12 now. And then our dx dt is still 2. That didn't change. Plus 2 times our y. 2 times our y, which is 5. dy dt, that's what we're looking for, is going to equal 0. That doesn't change. All right, so you can put in 2 and 13, but 0, it's still going to be 0. All right, and then if we do all this out, right, you're going to get, what's it called? Sorry, got distracted here. 2 times 2 is 4, times 12 is 48, plus 10 dy dt, right? And then you're going to get 10 dy dt equals negative 48, and you divide, and you should get, and it doesn't matter, you can keep it as a fraction or whatever, but you should eventually get negative 24 over 5 feet per second, right? Alrighty. This is example, let me get this back up. Example 6.